So in this video, just two examples of indefinite integration. I'm going to use, actually, I say use substitution, but I'm not going to use substitution. The first one because it's not necessary. What I'm going to use here is just recognition, and it's something that it will really, really help you to just take a second. It will really help you to integrate. This is really important. So look at this function for a second. Here's the function. I'm going to rewrite the function. I'm going to rewrite it, if you don't mind, as 9 minus x squared to the 1/2 power because I'm setting myself up to integrate. And then I look at this right here. I'm looking at this right here. And there's this dx. So this in the green is what I'm looking at right this second. And what I'm asking you is, what's the derivative of the inside of this function? And if I think we can agree the derivative of the inside of this function is negative 2x, isn't it? So this is a part of the derivative. Well, we don't want that, right? We're trying to find what function it came from. This was this is chain rule, right? So the person integrated this using chain rule. So I'm just going to do it backwards here, right? So I'm going to drop this, and then I'm going to write this way. I'm going to say, you know what, I have this 9 minus x squared to the 1/2 power, right? Oh, sorry. So I'm going to start my work here, and then I'm going to go ahead and integrate. So if you integrate this, you're just going to take this, and you're going to say 9 minus x squared to the, right? And when you integrate, right, we do all this backwards, plus 1, which is 2 over 2, isn't it? So that makes this to the 3/2 over 3/2. This is the rule of integration, right? Right? Plus c, right? Our constant of integration here. And then I'm just going to go out and keep simplifying this. I'm going to take this, remember, this is a complex fraction, so I'm just going to bring this up this way. So here's the 2 right here. Here's the, just so we can see where it's coming from, here's the 3 right here. I'll bring this up as 2/3, right? So it comes up as 2 over 3. That's me undoing this bit of work down here, right? Times 9 minus x squared to the 3/2 power plus 3. Right? So there's the indefinite integral of this. How, right, so you're like, sure, whatever. Okay, so let's prove this really quickly. Let's prove this really quickly through differentiation. So I'm not going to do this on the next one, but just show you on this one. So proof. So let's take the derivative, take dy dx. So dy dx of this thing is, right, here's our 2/3, so it's 2/3. This, right, this is going to come down here, isn't it? It's going to come down here. We're going to multiply it times that. So times 3/2, right? Times 9 minus x, shoot. That's all right. I might want to go back and fix it, sorry. Minus 9x squared. Right, then I'm going to decrement this by 1, so I'm going to decrease this by 1. That gives us our 1/2 back, doesn't it? And then, right, that's all I'm doing right here is taking the derivative of the outside, right? So I'm taking the derivative of the outside here times the derivative of the inside. So here's the inside right here. Now I am using the chain rule. The derivative of the inside here is negative 2x. So 2/3 times 3/2 is 6/6, which is just 1, right? It's just 1. So that, right, this is just 1 right here. And then we get 9 minus x squared to the 1/2 times negative 2x, right? And we know that that is where we started, right? So we started here and we're going to end here. So there's our proof through integration. All right, let's do one more example. And on this example, I'm going to work through a little bit more quickly because we're going to use this use substitution idea. And this is what I know about the AP exam. This is what I'm figuring out as things go. By the time you get to the AP exam, you have to know how to do this cold. So how are you going to get good at this? You're just going to have to do this and do this and do this and do this. Because on the AP exam, they're going to ask you to apply this. They're not going to ask you, find the indefinite integral of whatever. No, on the free response parts, they're going to give you a situation, and you're going to have to already own this tool, so it's less computational, more application. So let's find this one, please. Right? X cubed, x to the 4th power plus 3, squared dx, right? So here we have this integral. So what I'm going to do here, I'm going to look for this pattern, and I'm like, you know what, look, the derivative of the inside is 4x to the third power. Well, look, I got most of it right there, don't I? So what I'm going to do here is this u substitution idea, and I'm going to say this, let u equal this piece right here, equal x to the fourth plus 3. So then I'm going to take the derivative of u, du dx, the derivative of u with regard to x, and then take this derivative, which happens to be just what we thought it was, 4x cubed, isn't it? And if you look, this is what I'm saying now. See this x cubed right here? I knew I was going to get this. That's this piece. This is what I was expecting. I really was. I was okay with that. I was like, that's part of the derivative. But we're missing this part, so there must have been some factor out in front of f of x that ate that up. So what I'm going to do now is I'm going to solve. What I'd like to do here is just to tell you where I'm going with this. See this dx right here? I want to take this dx and I want to replace it with this one. So what I'm going to do now is I'm going to solve this whole thing in terms of dx. So we know that du, I'm going to multiply both sides by dx. Du is equal to 4x cubed dx, isn't it? Right? Remember, again, I'm looking for this piece right here. I'd like to replace this piece with this piece, right? Because I'm going to do this u substitution. Let's see what it looks like. So now I'm going to divide both. I'm going to divide both sides by 4x cubed. So we get du over 4x cubed is equal to dx. So hopefully you see what I'm about to do. Now I'm going to just do my substitution. So I'm going to sub. I'm just going to rebuild this whole thing. We have this. We have the indefinite integral of x cubed. Remember here, though, we have x to the fourth plus 3 squared. X to the fourth plus 3 is u, so u. And to the second power, this second power right here is this second power right here. And remember, I said in a perfect world, I'm going to replace this dx with an equivalent du value. So dx is this. So I'm going to put that in. It's du over 4x cubed. Now look at this for a second. These are all factors. I'm hoping you can see this algebra. So this is what I'm looking at now. I'm looking at this. Check this out. Here's this x cubed right here, isn't it? And there's an x cubed here. Isn't that true? And these are factors. So if we multiply this across, we'd have x cubed over x cubed. So can we agree they go to 1? Some of you will say they cancel out. They go to 1 here, right? So I'm just going to continue to simplify. Right? So I'm just simplifying this out a little bit. And I think this is going to work out good because here we're going to have derivative of, look, all the x's went away. It was kind of mixed up looking for a minute. We have x's and u's, but the x cubes go away, and we got u squared, right, times du over 4. See if you can't see this little move I'm doing here. Can you see the 1/4 now? Because what I'm going to do with this 1/4 is, see it? 1 over 4, so I'm going to pull this out to here. 1 over 4. Okay? And that, I know, I'm going to put the du back. So here's our du, right? Okay. Now, it looks like hell, but now it's gotten good. So now we can just integrate. So integrate. So here's our 1/4 times, this is not u to the second, but u to the third. So u to the third over, remember, whatever this number becomes this number down here. So 3, right? Plus c. And you're like, oh, are we done yet? No, we are not done yet. Oh, look. Oh, that's my problem there. Sorry, I brought a 1/2. It's a 1/4. Sorry, that should be 1/4 here, isn't it? Sorry about that. So caught that little thing there. I'm going to pull this whole thing out. I'm going to multiply. We have this 1. 4 times 3 is 12, isn't it? U cubed, right? There's our u cubed plus c. Now I'm going to, here, right, you have to get back to where we started, so I'm going to resubstitute. When you resubstitute that, you're going to get, well, go back and see what u was. U was, right here, right? We got it. Just going back to the beginning of our work, u was equal to x to the fourth plus 3. So I'm just going to go back and I'm going to put that back in if you don't mind. So our x to the fourth plus 3. We don't have the time, but if we did, I would say to you, prove this. So do that. Prove through differentiation. All right? Okay, you guys. I know some of you are sitting there going, what in the world's going on here? You got to get good at this. And the only way you get good at this is just keep doing problem after problem after problem. And just like everything you ever learned, it just sticks all of a sudden. It becomes the language that you speak. So, okay, I'm proud of you. Keep up the good work.